Assembler, pass 1 and pass 2 of assembler. What is assembler? What is assembly level language? Difference between assembly level language and machine level language. Comparative study between these two. Difference between 1 pass assembler, 2 pass assembler, and then pass 1 and pass 2 of assembler. First of all, what is assembler? What is assembler? What is assembler? Assembler is a system program. It is a system program. Assembler is a system program for converting assembly level language, LEVL, assembly level language into machine level instruction. An assembler is a system program for converting assembly level language into machine level language. It is used to convert assembly level language into machine level language. So assembler is a system software or system program that is used to take source code written in assembly language, then convert it into target code, that is machine language. Assembly language converted to machine language with the help of assembler. So assembler is a system software that is used to convert assembly level language into machine level language. So this is a conversion of assembly level language to machine level language technique. So it is a system software. Now the first one is definition of assembler is over. Now assembly level language, difference between assembly level language and difference between assembly level language and machine level language. There is a basic difference between these two languages. So first of all, column format, we have to understand this two level language with the help of difference table. First of all, machine level language, and second one is assembly level language. First of all, machine level language, and the second one is assembly level language. In first point, CPU can directly, is machine level language, that's why CPU can directly understand. Machine can understand its own language, directly can understand machine language. No need of compiler, or assembler. Means there is no interpreter, direct execution with the help of CPU. CPU can directly understand machine level language, no need of compilation or translation or assembler. Means there is no interpreter software. Assembly level language, programmer can, this is the first difference, programmer can understand the assembly language. However, CPU cannot, because need an interpreter. This is the first difference. CPU can directly understand machine language, no need of compiler or translator or assembler. Assembly level language Programmer can understand the assembly level language. However, CPU cannot understand the assembly level language. So this is the first basic difference between machine level. Machine level means machine level instructions that easily understand by CPU. So there is no need of interpreter to convert the language to one to another. But in case of assembly level language, programming style is written by assembly code. There is opcode and operand are there. So we need an assembler to convert the assembly level language into machine level language. So programmer can easily understand the assembly level language of CPU cannot. So this is the first difference between assembly level and machine level language. Machine language is in form of zeros and ones. Machine language is in form of zeros and ones. And assembly level language is English syntaxes. It is a English like syntax. So this is the second difference. The first difference was the CPU can directly understand the machine level language without any compilation or interpreter or assembler. Assembly level language, programmer can understand the assembly language, but however CPU cannot understand the assembly level language. So there is a need of compile assembler software. This is the difference too. Now third one, machine code, that is the machine code, differs platform to platform. It is depending on the architecture of the machine. See, machine code differ from platform to platform. This is the third difference. Assembly language is independence of platform. Assembly language is independence of platform because it is set of instruction. It is a set of instruction. It depends on instruction, not depend on platform or hardware system. So this is the third difference. The machine code differ platform to platform, but assembly level language is independent of the platform. However, platform, whatever hardware are there, it's not depends on that hardware. It depends on the instructions. So this is the third difference. Next, modification is not possible. Machine level, in case of machine level language, there is no modification is possible. Modification is not possible. So it is a different tough cases. It is a tough case to modify certain code. So it is difficult to modify. Now, modification is possible because there is a set of instruction, so we can modify the instruction. So modification is possible. Here modification is not possible. Here modification is possible. Next, the machine level language. The machine level language is not human readable. It consists of 0 and 1, so it is not easy to understand. It is not human readable. Assembly language is easy to understand, easy to read and develop. So assembly level language is easy to read and develop, and to modify it is possible. So these are the fifth differences. Modification is not possible, modification is possible. Machine language consists of zeros and one. It is consists of instruction set. It is machine language is platform to platform varied, but assembly language is not platform dependent. So these are the differences. Next, you can also specify this machine level language. Next, sixth difference. Machine language Machine language is the machine language are first generation program. It is the first generation program. It is a first generation program. Machine language are first generation program. And the 6 assembly language. It is a second generation program. It is a second generation. It's improved version of machine level language. Second generation. It is a second generation program. So it is a first generation program. It is a second generation program. These are the 6 differences. And the 7th one is there is no need of. এটা ফার্স্টেই আমি বলেছি there is no need of interpreter or assembler. There is no need of assembler. There is a requirement of assembler. There is a requirement of assembler. So these are the basic differences between machine level language and assembly level language. On সময় exam it আসে what are the advantages of machine level language and what are the disadvantages of machine level language, what are the advantages of assembler, what are the disadvantages of assembler. So advantage of machine level language is very fast to execute. This is the number one advantages. No need of assembler. This is second advantages. It is consist of 0 and 1, so CPU can directly execute. The third advantages. So these are the advantages of machine level language. But assembly level language is easy to understand, easy to create, easy to modify. So these are the advantages. So we can modify any instruction. It is easy to remember. So these are the advantages of it. Is English like synthesis. It is, but machine level language it has disadvantage. It is combination of 0 and 1. So it is not easy to read. So you can create the advantage and disadvantage from the differences easily. তোমরা এই differences থেকে advantage and disadvantage খুঁজে নিতে পারবে। তো এখান থেকে দুটো কোশ্চেন অ্যান্সার দেওয়া যেতে পারে, difference between assembly level language and machine level language, and the advantage of machine level language over assembly level language, and the disadvantage also. So you can create this basic concept. আবার বলছি এই কনসেপ্টটা যদি তোমরা নিজে থেকে ভাবো যে অ্যাসেম্বলি লেভেল ল্যাঙ্গুয়েজ মেশিন লেভেল ল্যাঙ্গুয়েজ ডিফারেন্স কি, ফার্স্ট ডিফারেন্সই পাচ্ছি মেশিন লেভেল ল্যাঙ্গুয়েজ মিন ইটস বেসড অন মেশিন, দ্যাট ইজ ইট কনসিস্ট অফ 0 and 1, it is series of 0 and 1s. In assembly language it is English like language, so it is easy to read. যখন ইংলিশ এসে যাবে easy to read, but machine level language is not easy to read. Machine level language is platform dependent because it depends on the hardware system of the computer. It does not depend because it is set of instructions. So it is easy to create, it is to modify. So these are the advantages and disadvantages you can write, and the differences between assembly level language and the machine level language. Now the passes of assembler. Passes of assembler. Passes of assembler. Every assembler consists of, you can create one pass, two pass or multi pass, but there are two pass of assembler. There are two pass of assembler. Two passes of assembler. This is the basic passes. Number 1, pass 1. Number 2, pass 2. These are the passes. Passes mean the algorithm methods. Pass 1 is analysis phase, pass 2 is synthesis phase. So assembler consists of pass 1 and pass 2. There is a pass 1 and pass 2. The source code is assembly code, assembly level code, that is the source code, and the object code is machine level code, and the object code is machine level code. There is a source code, that is assembly level code and machine code. Analysis phase, this one is analysis phase, and this one is synthesis phase. So the input of the pass 1 is source code, the output of the pass input of the pass 2 is the symbol table, literal table, this all tables. There is a machine operation table, pseudo operation table, and then pass to create the machine level code, that is object code. So this is the assembler, pass 1 and pass 2 assembler. Now pass 1. Pass 1 defines symbols. Basic purpose is it defines symbols used in literals and remember them in symbol table. and remember them in symbol table. Define symbols used in literals and remember them in symbol table and literal table. Remember them in symbol table and literal table. So it is used to define the literal. It is used to define the literals and remember them in symbol table and literal table. This is the first concept. This is the first one. And the number 2, there is a location counter to keep track every line. Keep track of location counter that is used to update every time. Keep track of location counter, LC. Next, process. This is the third point. Process pseudo operation. This is the purpose of pass 1. The purpose of pass 1 are it is used to define symbols in literals and remember them in symbol table, literal table, and it is used to keep track location counter every time it is updated. Every line is updated, so there is a update counter or location counter. This is also known as program counter. And there is a process pseudo operation. This is process pseudo operation. For this operation we need process pseudo operation table. We need POT, that is the pseudo operation table. So this is the purpose of pass 1. Now the pass 2. It is synthesis phase. So this is the purpose of the pass 2 is to generate the object code. The first point is generate object code by converting symbolic opcode. Symbolic opcode mean move, add, sub. These are the symbolic MVI. There are many instructions are there. Generate object code by generating the symbolic opcode into machine level language, into machine numeric opcode, so that CPU can directly execute those opcode. So in the past 2, it is the purpose to generate the object code from the different tables. Next, so it's used to generate data. It is used to generate data for literals, and for values of symbols So these are the functions of pass 2. So the pass 2, it generate the object code. Pass 2, it generate the object code by converting symbolic opcode. That symbolic opcode, like add, moves, such symbolic opcode is converted to machine level opcode and then generate the data for the literal and values for the symbols. So this is the purpose of the pass 2. So every assembler, generally 2 pass assembler, every 2 pass assembler আমরা করতে পারি কি একটা অ্যাসেম্বলারের মধ্যে একটাই পাস দিতে পারি, বাট সাচ প্রোগ্রাম দ্য ওয়ান পাস অ্যাসেম্বলার যেটা একটাই পাসে পুরো কাজটা কমপ্লিট হয়ে যাবে, অ্যানালিসিস সিনথেসিস, সেখানে প্রবলেম দেখা দিয়েছে। এই জন্য সায়েন্টিস্টরা যখন অ্যাসেম্বলার ডেভেলপ করেছে সেটা মাল্টি পাস করেছে, দ্যাট মোর দেন ওয়ান পাস করেছে, যাতে কি কিছু পাস 1-এ যে টেবিলগুলো যেগুলো নেসেসারি, যে সোর্স কোডটা স্ক্যান করার পর যে দরকার পাস 2 এর জন্য, সেগুলো তৈরি হয়ে যাচ্ছে, অ্যান্ড পাস 2 উইল কনভার্ট দ্য জেনারেটিং দ্য অবজেক্ট কোড। সো দ্যাটস ওয়াই উই নিড 2 pass assembler rather than pass 1 pass assembler. 1 pass assembler mean a assembler which consists of only one pass, that is analysis or synthesis done within single pass, and pass 2 assembler mean analysis done by pass 1 and then syntax after getting the data from the pass 1, it create the object code within the pass 2. So pass 2 is used to convert the to analysis phase and then synthesis phase. একটা কোশ্চেন খুবই আসে কোশ্চেন পেপারে, it is a common question, the difference between one pass assembler, and 1 pass assembler and 2 pass assembler, difference between 1 pass assembler and 2 pass assembler. 1 pass where analysis and synthesis is done within same phase, but 2 pass mean there are 2 analysis phase, and pass 1 and pass 2. First of all, 1 pass assembler, this is the single pass assembler, this is the 1 pass assembler or single pass assembler. Next is 2 pass assembler, this is the pass 1 and pass 2 assembler. So analysis phase and synthesis phase is there. This is 2 pass assembler, pass 1 and pass 2. Number 1, scan the entire source code, scan the entire file, that is the source code or source code, entire file or source code only once. Scan the entire file or source code only once. Scan the entire file and the source code only once. Two pass assembler, it is consist of a pass 1 and pass 2. That's why require two passes to scan source file, that is the scan the file in pass 1 for label, definition, and introduce symbol table It require pass 1 and then pass 2. It require two passes to scan the file in pass 1 for label and definition, introduce symbol table, introduce symbol table and in pass 2 it translate object code. So this is the basic concept of pass 1. Pass 1 means there is only one pass. Within that pass we have to scan the entire file and generate object code. That is the pass 1, and we scan the file as well as generate the object code. No intermediate pass is there. Now the second difference between one pass assembler and two pass assembler. One pass assembler cannot resolve forward references. One pass assembler cannot resolve forward references. Two pass assembler. Now in the two pass assembler, one pass assembler cannot resolve forward references. Two pass assembler two pass assembler can resolve forward references. One pass assembler cannot resolve forward references. Two pass assembler can solve the forward references. Next, third difference. No object program is written. Hence, no loader is required. In this pass 2 assembler, loader is required as object codes are generated. Loader is required, but in case of pass 1 assembler, one pass assembler, no loader is required. One pass assembler consists of only one pass, that is analysis synthesis pass done within single phase, so it is faster. Next point is the fourth point, it is faster. And two pass assembler, it is relatively slower. It is slower than one pass assembler. Next, address of symbols cannot be generated. Address of symbols can be calculated. So in this case, the one pass 1 assembler, no address of symbols can be calculated or generated. In two pass assembler, we can easily generate and calculate the address of symbols. So these are the basic differences. So in one pass, I am repeating the differences. In one pass, scan the entire source file once. In two pass, we required two phase. One in during the pass 1 label definition and introduce the symbol table. Pass 2 generate the assembly code, generate the machine code. That is the pass 2. Analysis phase and synthesis phase. Number 2 difference. Pass 1 cannot solve forward differences. Pass 1 cannot solve forward differences. Pass 2 can solve the forward differences. Next, no object is program is written, hence no loader is required. Here object is required, that's why loader is also required. Pass 1 pass assembler is faster. 2 pass assembler it is slower than 1 pass. We cannot calculate the address of symbol in 1 pass. We can calculate the address of symbol in 2 pass. So these are the basic concept of 1 pass and 2 pass assembler. Why 2 pass assembler is more popular than 1 pass. These are the points you can write in examination. So this is a very important question in semester examination.